Hi, and welcome to today's session on Pragmatic Python. This meetup is jointly hosted between UpSkill ML, a meetup focused on empowering technical professionals to solve their organization's most challenging problems, and Data Education DC, a meetup dedicated to democratizing data science within the DMV area. And in collaboration with Deep Learning Adventures, a meetup focused on positive change through deep learning. In today's session, Eugene will be going through part 3 of his Pragmatic Python series. Here, Eugene will be covering nifty tricks and how to create your own context manager. Eugene is a full-stack data scientist at a Fortune 100 company, a 4-time hackathon winner, and an open-source contributor to Dask. With that said, let's hear from Eugene.
Awesome. Perfect. With no further ado, let's begin tonight's talk. Advanced Python, the Pragmatic Python series, but today's topic is procedural Python, code like a pro. So, as Josh mentioned, here's a quick intro. I'm not a CS major. I took 2 CS courses, got a B+ in both of them, unremarkable. So primarily, I'm a self-taught programmer, not academic. So my perspective on things are what's interesting and fun, and less of the academic problems. For example, here's an academic problem. You might see an undergraduate computer science course, right? Like, that is not fundamentally interesting to me. What is interesting to me is large-scale data transformations and figuring out how to make Python do cool things, right? So, as Josh mentioned, I'm a 4-time hackathon winner, PhD certified data engineer, consensus certified blockchain developer. I specialize in distributed computing, large-scale transformations of data. So I've ETL'd 150 terabytes on one machine before, and I've also run my own custom graph partitioning algorithm that I wrote for myself that parallelized across 62 machines. But enough about me. It's not about me. It's really about you and what you can learn. So tonight's course, I'm going to go over procedural Python and go over expression versus statement, pass, break, continue, if, elif, else construct, for, else construct, while else construct, try, except, else, finally, that to a context manager. So, like, many of you might know already, like, the first 2 topics, or 3 bullet points. Some of you might not know the 4th and 5th one, but the main one I want to show you today is the 6th one. Sorry. So, why did I make this course, or make this? I made a tutorial on how I wish I lived. So on the left-hand side, we have Zed Shah, who wrote the someone wrote Curio. Let me try to paste it right now. Let me put it in chat. Perfect. So what mybinder.org gives you is a free container you can run right in your browser. So it connects to a container, and it basically downloads and sets up the virtual environment for you, such that you don't need to git clone, you don't need to pip install, you don't need to do anything. The environment is set up in a container on the cloud somewhere that you can connect to right in your browser, so you run the code alongside with me. And if you have any questions, if you get stuck, or your code ran into error, feel free to ask me. Feel free to interrupt anytime to asking questions, because I think perhaps the content of this talk is quite large in scope, so we might break this talk into 2 talks. So feel free to ask a question anytime you have any problems. But if you get that first link, the mybinder .org link in your browser, you're ready to go. It takes about 30 seconds to start up. So I will do that myself. So while it's starting up, we'll go through we'll go through these topics through here. Mastering control flow. So I actually have one set up already. So let's just go through that one instead. Oh, that one's dead. Let's go through this one. Perfect. So what is procedural Python? What is procedural programming? There's some boring academic explanation. You could feel free to skip that. What are we going to do in reality? What do we care about as a pragmatic Python developer? It's basically control flow through conditions, loops, iteration, jumping, and exception handling. So don't be like Bruce Lee. Don't be like water. Be like the airbender. Bend the control flow to your will. So let me start off with some, let's say, ground rules or ground, explanations of like what things are. So what is the difference between an expression and a statement? So a statement evaluates something and returns a value, like 1 plus 1, or range 10, or any function call. That is an expression. But statements do something but are not always assignable, right? Like these keywords inform that you're about to do a statement, right? If, to accept, pass, break, continue, so on, right? So technically speaking, all expressions, so any function is a statement, but some statements are not expressions. And how you know which one's which is that if you could sign equals to something, then it's an expression. If you can't put equals, then it's a statement. For example, expression can take parentheses to stretch the body across multiple lines. Like let's say print, right? Print itself actually is a function. Print in Python 3 is a function, but not a function in Python 2. In Python 2, print is a statement. So you cannot nest prints together in Python 2. But that's been rectified in Python 3. Because what does print return? Print is a function in Python 3, and it returns none. That's how you can tell. And because print returns something, you can actually assign it to something. And that's how and if you print it, then you verify that it indeed print returns none. So print is an expression, and thus a statement. So in fact, this line cannot be run in Python 2, but it can be run in Python 3. So I print this says hi, then which returns none. So then I print none and thanks. That's you get this line, and then that itself returns none. So if you print that again, you get none and bye. So that's a cool thing in Python 3 that cannot be done in Python 2. So statements, on the other hand, do not need parentheses. I guess you can put them, but you don't have to. For example, return is a statement. Because why? Because you can't say x equals return 1. That's how you know it's a statement and not expression. Because the return on that same line is not assignable. In Python, the statements do not need parentheses. For example, if you are coming from R, right, you need to put parentheses around your return. Not so in Python. So like just this week, I think it was just yesterday, I saw an R programmer program Python. I noticed, hey, you're an R programmer. And she said, how did you know? I said, well, you put parentheses around your return. Here's another example where actually you don't want to put parentheses here. So assertion is like, I'm asserting some condition, right? This is my Boolean, and this is false. So it will always raise an assertion error, right? So this is expected behavior based on this line, right? This is a statement because I cannot say x equals assert. That's even more invalid than the assertion error. But be careful here. All of a sudden, if I assert this, it goes through. What happened? So can anyone guess why this assertion went through when obviously it says false here? Quite a puzzling thing. I'll give you a hint. Because you put parentheses, now this looks like this. That's what it's asserting. So can you guys see why this tuple, actually any non-empty tuple is actually logically true. So when it looks like this, it looks like assert I'm using it as a function, but assert is not a function. It's a statement, or it's a keyword for a statement. So once I put parentheses around here, it no longer thinks of this false condition. It's looking at this composite object, which is a tuple. So a non-empty tuple is basically like this, and this is always true, right? If I had made it into an empty tuple, then this is false and the assertion error will be raised. So in this specific case, what I'm trying to illustrate here is that this keywords that inform you that it's a statement may or may not take a parentheses, unlike function calls. And sometimes, in this case of assert, putting parentheses will actually nullify what you're trying to do in the first place. For example, you also don't want to, for the delete operator, right? You don't want to put, let's see, I have x variable x, y equals none, and I want to delete both x and y. If I start putting parentheses around here, now it will actually fail. Well, actually, actually succeeded. Surprising. So I guess some things behave well with parentheses, some things don't. But that is a quick pass through expression through versus statement, and that will become more important later on in this talk. I'll quickly go over another simple thing that's probably a warm-up for most of you. So pass is a no operation. It doesn't do anything. It just tells the computer to do nothing, or oftentimes it's a temporary placeholder for when you want to actually fill out real code later. Pass is a statement. It is not an expression, so it cannot be saved. So in this case, pass here is to, if there's any problem, just continue as usual. Here, this is the most common case of seeing pass, right? Pass is just used to fill in the blank, and it's a temporary. It's like a to-do, like put in this code later. But pass is not an expression, is a statement. So this line would fail. So that's pass. Nothing special here. Now I'm going to quickly just review break and continue before we get into the meatier topics. So if you're starting in Python, what is the difference between break and continue? They both exist within loops, but break is when you want to stop the loop immediately, essentially prematurely exit out of the loop, whereas continue means to skip the rest of the body for this iteration of the loop and go back to the top of the loop to start the next iteration. For example, here in this code, all I'm doing is appending values to this accumulator list. If it's 3, then just stop and do no more appending, right? So break means like I will go to 0, 1, 2, and once it hits 3, I break. It means I exit the loop prematurely. I'm finished. Whereas continue is similar, but not identical. So if I do continue, it goes 0, 1, 2, 3. Then when I hit this condition is true, I continue. So basically it means skip the rest of this iteration of this loop and go to the top. So the next time I equals 4, this condition is false, so the continue is not triggered, and just continue appending. So the difference between break and continue is seen in this result. When you hit 3 in the break, you will just prematurely stop, and that'll be the end of that loop. But where you hit continue, it means just stop for this iteration of the loop, but continue with the other iterations of the loop. So that's a quick, warm-up. let's try something interesting. So the if-else is still a warm-up, but I want to share with you the for-else and while-else construct. Things that you might have not seen from before, because in other languages, they do not have a for-else or while-else construct. Let's go over if, elif, else construct. This is probably familiar to most of you. So if a certain condition is do this, but elif means else if, and if a different condition is true, is do that. So if none of the previous conditions are true, then do else. So in the if, elif, else clauses, you can have multiple elifs, but you can have at most one else. Let's just go through an example. So in an if, elif, else, only one of these conditions is triggered. It's either triggered here in the if, or it's triggered in one of the elifs, and if none of those are triggered, then the else is triggered. So exactly one of these clauses will be executed. The difference is that notice that if you have multiple if conditions, both ifs can be triggered, but in an if, elif, else, only one of them can be triggered. Not too terribly exciting. So this is FizzBuzz. So the role in FizzBuzz is if a number is a multiple of 3, print fizz. If the number is a multiple of 5, print buzz. But if the number is both a multiple of 3 and 5, print FizzBuzz. Otherwise, just print the original number. So here, I'm trying to illustrate when clauses can be executed. So in this if, two ifs, actually both of these ifs can be triggered. So if it's a multiple of 3 and 5, actually both of these are triggered. But that's actually the incorrect behavior, because you only want, if it's a multiple of 3 and 5 simultaneously, let's say 15 or 30 or 45, then you want to print FizzBuzz. So this is actually an incorrect implementation of FizzBuzz. And in this case, what is wrong about this? Now we have if, elif, elif again, and then else. So what is wrong with this? The reason why this one is flawed is because if you have a multiple of 3 and 5 simultaneously, the first one's triggered. So let's say if you have the number 15, what gets triggered? This clause is not triggered, but this clause is triggered. So it will print this one and not ever hit this clause right there. So this is also incorrect implementation of FizzBuzz. Right? So here is the correct implementation of FizzBuzz. Well, exactly one of these conditions will be triggered, and you want to stick this joint one at the top. So if it's a multiple of 3 and 5, print FizzBuzz. Otherwise, check the condition to see if it's 3 or 5, and if it's none of those above, then just print the original number. So here is an example of the incorrect implementation. So 15 is a multiple of 3 and 5, but you only want to print it. You only want to print FizzBuzz. So this is incorrect. This is also incorrect because it checked to see if it was a multiple of 3 or 3, so it printed fizz, but it's a multiple of 3 and 5. So it didn't print FizzBuzz as we wanted. It only prints fizz. So now here, this is correct implementation, prints FizzBuzz. Right. So that was just a artificial toy example to show if, elif, else. For most people, that's still warm-up. So let's try something more interesting, right? The for-else construct. Most people are aware of for loops. That's what we use every day. For, while, loops. But what is the for-else? So the else clause in for is only executed if the loop completes normally. That means you've iterated through all the elements in the for loop, and you did not break prematurely. You can use continue, but not break. So for else is useful when you want to determine if there's an early exit, either from a break. It's primarily break, not the return, because if you return, then you obviously return and you don't care about the rest of the loop. So it's primarily the else detects if you used a break or not within that loop. If you did not use a break and you had a natural exit, meaning you looped over all the elements, then else is executed. In fact, if you don't use an else clause, you can manually replicate it using a flag-based approach, which I'll show you. In fact, the fun fact is Raymond Hedger, a core Python developer, said in hindsight, this use case of else should have been called no break instead, because that's what it really is. The else in the for loop is really no break. So in this case, in the for loop, if I equals 5, right, break, right? Although if there was no breaks, then execute this line. So in this case, it broke, so this clause was not executed. In this case, this iterated through all the elements of range 10 perfectly fine. So this else clause actually is executed. So how would you do that if you did not use the else in the for else construct? The flag-based approach is to constantly check to see if you had a breaking condition or not. For example, here's the flag. We're going to set this none, or you can set it to false, basically. None or false, it doesn't matter. So if the number is odd, or even, sorry, if the number is even, then turn on the flag. So you hit a breaking condition and then break out of it. And this line replicates the else. So if you did not hit an even number, then print no even number seen. So this is the equivalent of the else clause if you don't use for else. So these two cells are logically identical, with the exception of the for else. You don't have to explicitly define a variable because it's basically done by the for else construct itself. Let's see. So basically, the else in the for loop saves you two lines: defining the flag variable and setting the flag variable to be true once the condition is hit. And it also replaces one line of checking the if condition at the end. So that's basically this. So like the for else is there for you if you want to use it. Basically saves you two lines. Not a big deal. The while else is actually very similar to that. But before we go to the while else, does anyone have any questions?
Learned something new. Thank you.
Perfect, perfect. All right, let's go to the while else construct. It's very similar to the for else. Basically, the else and the while else basically checks if you didn't have an early break in the while loop. Like you did not prematurely break out of the while loop. So in this case, let's give an example. While I is less than 10, just increment it. And if you hit I equals 5, just break out of it. So in this case, since you broke out of the while loop instead of naturally or gracefully or exiting the loop, then this else is not triggered. But in this case, the else is triggered because you did not break out of the loop. You naturally exited out of the looping condition. So then else is triggered. And again, this could be replicated with a flag-based approach, setting the early break flag to be none or false, and then switching it to true if a condition is hit, and then breaking out of it. So you just have to set the flag to be true right before you break out of the loop, and that you could easily replicate the while else construct using just a flag, binary flag. So that's while else. Very simple. If you find use case for it, that'd be cool. So in other languages, especially let's say C, there's actually something called a do-while loop. Python actually does not have a do-while loop, and the primary reason was very simple. The creators of Python could not figure out how to do the indentation syntax that would allow a do-while construct. So to do a do-while, you just do this construct instead, and you put the looping condition at the bottom and the negation of that condition, and then you have do-while. So in C, the do-while is do some work, then while's condition is true, keep on looping. In Python, since we don't have curly braces to denote bodies of loops, we have indentation. The equivalent would be to do while true, do work, but instead of checking for the condition, we check for the negation of the condition and then breaking out of it. So that's a do while loop. And if you've never seen a do while loop, don't worry about it. Python programmers don't use it, and it was just purely for completeness and as a cool trick. Not important. But this is the juicy part of the talk tonight. Try, except, else, finally. This is what I was really getting to. The other stuff was intro and is also for completeness. Let's do try, except. So most people are aware of try, except, but many people are not aware of the try, except can have additional clauses of else and finally. You can have multiple else clauses, but you could have only at most one finally clause. But some people say, oh no, don't use try except. It is so slow. That's what I was taught when I first started Python. Just just use try except very sparingly. It's very slow, you know. And let's debunk that myth. That is not true. Try except is not slow. It's actually super fast. It's as fast or faster than the if statement, given you don't hit an exception. If you hit an exception in the try except, it'll be only slightly slower. So basically, I'm giving you free reign to use try except anywhere you want. So let me show you empirically how supposedly slow try except is. So in this case, I'm just iterating through, I think, 10 million times. Yes, 10 million. And I have an if here, and it's basically no op. Nothing important is happening, right? So it's just looping through 10 million times, doing nothing. This time, I'm going to try except. I'll try this thing, basically, essentially no op as well. Nothing important. And look, 692 milliseconds versus 610 milliseconds. There's effectively no difference across 10 million iterations of an if versus a try except. So try except is actually very fast. So the slowness comes is when you use a try except and hit an exception. That's when it starts being moderately slower. So looping over this try except where an exception is raised and you do catch that exception over 10 million times, that only takes 2.91 seconds. So it's less than a literally less than a microsecond per try except. So try except has a penalty of less than 1 microsecond. So try except is very fast. Don't worry about it. You can use them anywhere you want. Don't worry about it. That won't be the bounding factor for the rest of your code. All right. So when I was an intern many years ago, my mentor said, do you know about the Pokemon catch 'em all exception? I asked, what is the Pokemon catch 'em all exception? And he said, oh, that Pokemon catch 'em all exception is that when you have bare except. So when your code looks like except colon, or except exception, or except base exception. The base exception you won't see most times, so it's mostly just the first two. So whenever you see this English try except, that is a Pokemon catch 'em all bear exception. And that's actually undesirable because you always want to catch a specific exception type, and you don't want to catch the exception types that you did not expect. So let me give you an example of that. How divisive? How divisive takes two variables, x and y, and it checks to see if both variables are numeric, basically, so I can divide them. So this is basically just a division function, right? X divided by y, nothing important. And I'm just checking to see if they are numeric, that it is possible to divide. So now I'm going to try to divide 3 and the string high. Obviously, that will fail, right? And then this function raises a type error when you're doing invalid type types as arguments, right? So that's to be expected, right? Perfect. So this is good, clean code, ideal, right? But what if you did this? You had a Pokemon catch 'em all exception, which you catch any type of exception right here. Type exception, a type error, key error, value error, zero division error, or I guess in this case, you actually do have a zero division error. So, in this case, your function actually catches type error, so you're fine, but you did not consider a zero division error. So if you did a bare except right here, you basically suppressed a useful error message. So it's undesirable to have a bare exception or Pokemon catch 'em all exception. This is a specific case where you've suppressed a useful error that you didn't anticipate ahead of time. All right, so let's do try except with multiple exception types for different error types. So here, I'm going to do 1 divided by 0, which obviously triggers the zero division error, right? But you can also put other types of exceptions here and intervene in a different way. So given a zero division error is raised, this is how I intervene. I'll do this. Given this other type of error is raised, let me do that. So here, division by 0, I trigger this one. But now let's say I now want to trigger the key error, right? I have this empty dictionary that I've checked a key that doesn't exist. So now I'm triggering a key error. And then you see, oh, this key error is caught by the except, and I intervene in this manner. The body of this clause is executed. So now let's go to another example where you catch multiple types of exceptions and intervene in the same way. So I'm going to try this body. This is the expression that I'm trying to run. And if I get either name error or index error, do this. So the actual error is the name error because this variable x is not defined. So it's triggered by the name error, and then boom, you got this. So here, I'm going to show you how to create your own custom exception. So there's type error, value error, key error. There's over a dozen, I think over 2 dozen built-in exception types if you check on the Python documentation. But how can you create your own custom exception for when you do something, you want to catch your own exception, right? Specific to your own programming needs. So I'm going to catch this, I'm going to create this custom exception, and I'm going to catch it. So here I'm raising the exception. So any custom exception have to inherit from the exception class or any of the subclasses of exception. And this is how you raise it, so nothing special here. But here I'm actually using a bare except just for a demo, right? Like you shouldn't ever use this code, or you should use it very sparingly. But I'm going to catch this exception, save it to a variable called E and try to interrogate it for results, for intel. So here, in this exception, when I raised it, I gave it this message, right? So I can extract the message. I can even extract the type of this exception, right? The type of this exception is you're exceptional. So you could re-raise this exception. Boom. Or, like you inject a slightly different message, right? Let's say type E, and, the message of that type. And I want to make it very important. I want to uppercase it. So now I said, oh, instead of you are the best, I made the message like, uppercase this, to maybe highlight, oh, this is a really important exception, figure this out, right? So this is how you catch exceptions, save in variable, and then interrogate for results. In fact, after that block is run, this variable E disappears. So it's gone. It's gone. So the exception, after you catch it, cleans after itself. So there's no variable leakage, unlike in Python 2, which I believe the variable would leak, but not in Python 3. So before I head into the next topic of the else and finally blocks in a try except, does anyone have questions so far?
Referencing Python 2 oddities, this kind of seems weird because no one should be using Python 2 for such a long time, right?
Yeah, Python 2 was also deprecated, I believe, at the end of last year, and officially like earlier this year. Someone asked me, what leaked in Python 2? Let me show you in Python 2 how the exceptions leak. And also even list comprehension, like I think a terrible bug of Python 2 is that list comprehension variables also leak. So that's just quite unfortunate. The division error. So let me give you an example of this is Python 2, 2.7. I'm gonna run that. Oh, Python 2, fortunately, the exception does not leak. All right, I was thinking something else. This leaks in Python 2. So in Python 2, it's unfortunate, but this variable, this iterator variable, this variable that iterates through your container or list or set, dictionary, or whatever it may be, it exists outside of this list comprehension, and it's here. So let's say, like, I actually had a variable called x, like my very important variable. And then you ran the list comprehension, and unfortunately, it had the same variable name. Boom, I've lost my variable. So this x is no longer my very important variable. It's whatever is the last thing in my looping condition here. So that's unfortunate in Python 2, but that's no longer in Python 3. In Python 3, there is no problem here with leaking the variable, and you're fine. So if I print x here, it will still say my important variable. So Python 3, that's been rectified. Does anyone else have any questions? All right. Before we head into the next section of else, and finally, we could take, let's say, a 5-minute break, to get some water, take a break, and then come back. And we'll meet back at 6:55. And if you have any questions, like while you're running through mybinder.org or anything else, if you have any questions, feel free to ask me or post in the Zoom chat. All right. Let's take 5 and come back at 6:55. All right. Let's see how far we can go tonight. All right. So most people have seen the try except. Let's throw an else, and finally. So else in try except is executed only if except is not triggered. If you remember from else and for else or while else, those else are basically no break. If nothing was triggered to break out a loop, unnatural. If things worked naturally in those loops, then else is triggered. That is the same in a try except. If you try and everything works and there's no exceptions, then the else clause is run. And then finally is run and executes no matter what. No matter what. Even exception is executed, finally will always execute no matter what. So let's go through the example. So for else, you can have at most one else and at most one final. So let's give an example. Let's put this into practice. So if you raise an exception, then the else is not triggered. So here I'm doing zero division error. So like the except is triggered, the else is then suppressed or not run. So this is a normal division. So like the result is 0, totally fine. This exception is not triggered, and then the else is then run. So only run the else clause if you do try. If everything in try works fine, else is run. So let's take a look at finally. This one's very interesting. This one is very interesting, right? Let me actually hide the answer. But I said try, and if you use try, you could just try and finally. You could even skip the except and else. But let's take a look. So I'm going to try, and I'm going to actually assert a false statement. So this assertion will be raised. So I'm actually raising assertion error right here, right here. And then I will print. And finally, which I told you should execute no matter what. Should print this and then return 1. So what do you guys think will happen when I actually run this function? Will I hit an assertion error, or will I not? Does anyone have any guesses?
Get the result.
Oh, can you say that again?
It said it's going to give the finally clause.
Yes, it's going to run the finally clause. So it's going to run the finally clause, right? So even if the assertion is tripped up, I will still run my finally no matter what. So it's going to print. I did that print, and actually did a return. So that I've basically suppressed any exception here because I've always run finally no matter what. So now this is going to be another interesting question, right? I'm going to raise an exception, so I'm going to trigger this assertion error. So this one will be triggered, right? Let's look at this very carefully. It's just a fun brain puzzle. You wouldn't actually write this code in real life, but as just a thought exercise, what would happen? Right? I should print this exception error, which would message, right? So I should print this thing, and then I'm going to try to return 2. And I'm going to actually return. This is actually a tuple here. I'm returning a tuple. The first element of the tuple is 2, and the second element of the tuple is none, actually, because after this is printed, print returns none, right? And then I'm going to run, finally, I'm going to run another print, and then I'm going to return 1. So here is the thought logic puzzle. What is printed and what is returned? Does anyone have a guess? All right, I'll walk you guys through this one. It is a tricky one. I wrote this intentionally in an artificially, annoying way, just to, as a proof of concept of like what actually happens. Like, actually, don't write this code in real life because it's horrible. But so this is what happened. So first of all, like this runs in fairly like top to bottom manner, right? So I try to run the try body, right, assertion has been raised. Then what do? I look through the rest of it, right? So like, if I had, so the next, immediately after the try is the except, right? So I catch this exception, and I store it in this variable called e temporarily, and I print it. So like, this exception error message has been printed successfully. So this has been falsified here is this message right here. So the print works normally. That's great. Then I'm trying to return here, but the return has to evaluate this expression first. This is expression, and I guess here's the entire statement. So it's trying to, so it evaluates this tuple. It evaluates 2 as 2, nothing there. Then it tries to evaluate this expression. So that's printed right here. So this has been printed. And then this print is replaced with essentially a none. Because print in Python 3 always returns none. So it's trying to execute this line here, but I told you that finally is executed no matter what. So before it can actually, it's executed this tuple so far by virtue of printing the print expression, print function. So, but it's right before it does the return, executes the finally. So finally is now printed. I will always run, and the finally return supersedes the return here. So basically, whatever exception, even if it's assertion error, type error, key error, value error, it doesn't matter. The finally is always run, and in this code I wrote, it returns 1. So I've basically suppressed all errors, no matter what. So like, obviously this is not ideal code, but that goes to the thought logic of this convoluted try except finally logic here. Does anyone have any questions on this piece of code?
That makes sense. Can you raise an exception here finally?
Yes, you can. So like, if you raise another exception, now the return will not execute because you just raised.
Okay, cool. Thanks.
And even if you didn't, let's say you did not raise this assertion error, you raised a different error. Let's see, 1 divided by 0. That gives you 0 assertion error, or 0 division error. This is not triggered, but the finally is still triggered. So you still return 1. So basically now, with if you do a return in the finally, then you suppress all errors, and then now you can't find the source of your problem. Let's see. This is an interesting example, but not too important. All right, so let's do a try except else finally in its full glory, right? Does anyone want to take a stab at what this code is going to do? Like what the order, well, what's going to print and what's going to return? Actually, it doesn't return since this is not a function. All right, let me walk you guys through it. So I do a try, and the pass is just a pass. It's no op, so no operation here. So like none of the exceptions are triggered, but here I'm showing that you can catch multiple exceptions. You could catch and intervene for 0 division error. You could intervene for key error, and you can simultaneously intervene for a name error and an index error, and do this. And if there's any other exceptions that were not previously caught, use a bare exception here, which is not ideal, but if there's another exception that you didn't anticipate, you can catch it here, through here, and then print this thing. But if no exceptions got triggered, then run else. So in this case, when I try, everything's fine, so the else is triggered. So that's why it prints I'm going to trigger an exception. Right, so this printout corresponds to this printout. But now And the else is interesting. I'm raising an exception there, right? So technically, you would think that this code body just dies right here, right? It should raise an exception, right? But before an exception is raised, the finally block is always run, no matter what, right? So in the finally block, I'm going to print first before my exception is raised. So next thing I'm going to do is print. Hey, I just want to say something right here. So this line is printed here. And then the exception is fully raised. So here's the triggered from this else clause's exception. So now you can see that the code is running in a kind of a non-linear fashion, right? It runs top here, it checks the condition, this exception here, these are not triggered. So it hits the else. So it runs this. And then before this is, technically it would hit this, but kind of pause and run the finally first, and then complete the execution of raising exception. So that's how that logic goes through. Oh, wow. All right, so I think this is my last example of, try, except, else, finally. So let's go through the example. I'm going to try to do this no-op. So that means we could basically skip all this, right? So none of the exceptions are triggered, so you could basically skip all that. Then I'm going to hit the else, and it's going to print this, right? So I print right there. I'm going to trigger an exception, printed right here, right? So now I'm raising an exception, but I also have a finally clause. So does anyone have a guess what is the final thing out of this function here? Is it going to be an exception, or is it going to be a return?
Because the finally is doing a return does not suppress the exception.
Yes, exactly. That's exactly correct. So when you use a return and a finally, you've basically suppressed any errors. So it returns one, and basically if your code is broken, you'll never know about it. So yeah, so the finally, if you return finally, then you suppress all exceptions, and this is no longer raised. All right, so let me quickly go through an actual use case of finally. Why would you ever use a finally in the first place, right? Finally is when you want to clean up your environment, release resources, close files, close databases, basically clean up. After the work is done, do something. So if you are connected to a SQL database but hit an exception during query, you might have not released database connection when that exception is hit. And a database has a limited number of connections it can handle at any given time. So if Python does not release that connection to the database, let's say SQL database, then no one else can actually run any queries upon that database. So what you want to do in the finally block is you want to clean up your environment, right? Close any dangling database connections, close your files, write any final logs you have that you care about. Maybe that's where you do your runtime profiling, right? You start with a timer at the beginning of the function call, and then in the finally block, that is the end time, and then you print out how long your function has taken. Right? So, boom. That awfully sounds like a context manager, right? That's what the with open context manager does, right? If you hit any exceptions, automatically close the file no matter what, right? So you can replicate that with a try finally clause to create your own custom context managers. So I'm going to show you an example where I do not use a context manager and have corrupted my state, corrupted my file. So here I open a file and I want to write this thing, so write my secret message, and I hit an exception that I didn't expect, do some work here, but I hit an exception. I'm trying to write another thing into my file and then close the file, right? So if I didn't hit hit this line, everything should work perfectly. But because I hit some exception, I didn't actually close my file. So now, like I hit the error, right? And I'm trying to read my file, and my file is lost. The file is lost, even though you try to write this message, right? What if you had that one-time message secret, right? And you've lost it. Now it's gone, lost the history of time. That's not good, right? Now, depending on your operating system, let's see if this works. In Linux it works, but in Windows, like you can't even delete the file because the file descriptor is still open by Python. So in Windows, at least you corrupted your environment and you're screwed. I guess Linux is smarter. So what you would do is that with good Python programming, you do a context manager and do with open, and even if you hit the exception, what you do, the file will close. So at least you can extract the contents you wrote to the file before you hit the exception. So that's what the with open context manager does, right? But can you replicate that with your own try except context manager? Yes, you can. So here's how you create your own context manager. You import the context manager from context-lib, apply a decorator on it, right? Not important. But here, what I want to do with this custom context manager is the time, how long it takes to do something. That's what I'm interested in. This is basically a runtime profiler, right? So before I do something, I'm going to start the time, print, the start time, and after the thing is finally done, I will collect the end time and then print out how long it takes. So here in this function here, or in this like body of this context manager, all I do is like sleep for 5 seconds, right? So suppose this is like a very CPU intensive thing that takes a long time, right? And you want time, runtime profile it. This is what you could do. So when I open this context manager, it starts the timer. Once the body of that code is finished, then I collect the end time and I print how many, how long it took, right? And that can be chainable. So like if you have multiple functions, you could time the whole body of that context manager. So wait 1 second, 2 seconds, 3 seconds, so 6 seconds, right? So boom, total runtime of this block code, if you're curious about runtime profiling, is 6 seconds, right? And it even works with exceptions. So I try to sleep for a second, then I'll basically raise a zero division error rate. And even when the zero division error is raised, I still am able to perform my end time and then print out the total time before, like right when it died. So that would be a useful case of that. Of the try finally construct to create a custom context manager. So does anyone have any questions upon that?
I do have a question. Suppose within a try block, if I'm trying to do multiple things, suppose uh, casting, and then if one of the casting resulted in an exception, but I still want to run this rest part of my try block, so can I do that?
Oh, so let me repeat the question you mentioned. Did you say when you're casting some object to a different object and it causes a failure, will this custom manager, context manager, still print out the runtime even if it fails? Is that your question?
Yeah, yes, and also additionally, can I run the rest part of my try block?
Ah, yes. So the try block is really the body of your code. So this is your try block. that represents this thing right here.
Mm-hmm.
So this is the try, and if anything fails, if it succeeds, like try to do whatever you want to do in the body of your code, and if it fails or succeeds, no matter what, run the file name block, right?
Mm-hmm.
So let's say I'm casting, right? So like I do a sleep, and then I'm trying to do integer of a string, right? Integer of float, right? Like that. This is nonsensical, right? This will raise a value error, I think.
Right.
Yeah, value error. So can this still work? And the answer is yes. So wait for 1 second, hits the exception. The value error is raised, so like you still get the value error, great. But
Okay. Okay.
total time is still here. So
Okay.
the context manager that I created here only does timing. So any exceptions that naturally get raised still get raised at the end. So I've not suppressed any exceptions.
Okay. It will. Okay. Okay. Got it. Thank you.
No problem. No problem. Does anyone have any other questions about the custom context manager? All right, we're into our last section. This is the case switch statement. In other languages, or like in SQL or something like that, you have like the case when. In, I think is it Java or C? You have the case switch. But this is how it looks in Python, right? If something is this, return that. Otherwise, elif if this, return that, right? Like you just have a bunch of conditions, right? And you're like, oh my gosh, I just have a vertical spacing here. I have like a bunch, like 10 if conditions, right? Like, can I do better than that? The answer is yes, right? This is how you do it in SQL, right? When some condition is true, then that. When some other condition is true, then that, and so on, right? This is how you do it in C, right? So how do you do it in idiomatic, pragmatic Python? You use a dictionary. So this is logically equivalent to this right here. So if you have a bunch of if, elif, else, you could do that in the dictionary. How? If the condition is 1, or if get this thing, then return 1, or January. If 2, return in February. And you have the else at the end. If none of those things are true, then get the default option. So in a dictionary, you can get arbitrary like keys, right? But what happens if you get like non-existent key, right? It raises a key error, right? But the cool thing is that if you use the .get method, this is always safe no matter what. So this will not fail. So if I want to get an existing key, that's fine. I get 4. If I get a non-existent key, that's fine. It returns none. Or it returns a default value. So default. So if you get a key that does not exist in the dictionary, get the default value. So that's what I did here. So get the value for a given key. If that key does not exist, give me the default value. So if I get month 3, I get March. But if I ask for month 13, that doesn't exist, so I get the default value here. So month 13, month 15, right, also get the default value. Month 100 get the default value. But if I did get month 1, I'll just get January. Right. So then I could do this, right? So instead of doing 5 if statements, if, elif, else, I could just do it in 1 line in a dictionary and do that right there. And so my last thing to conclude this talk tonight is that how can you do that for functions or methods, right? What if, so in Java, there's something called method overloading, where given different type of the argument, do something different. You could do the same thing in Python. You could do essentially the equivalent to method overloading using the single dispatch decorator in Python. So suppose you want to create different versions of the same function where each function did something slightly different based on the type of the argument. Each version can have the same function name, but they could behave differently based on what the argument is. So if I added, like, let's say I created a function called summer, right? It just sums up, or like multiply, right? Given a string, it can multiply in a certain way. Given a integer, it can multiply in a different way using the single dispatch decorator. That will be introduced and explained in 4 functional Python notebook. So in a future talk, but there is a way to do the equivalent of catch case when or case switch, but for method calls. But that concludes tonight's talk on procedural Python, mastering the control flow in Python. Does anyone have any questions?
There was a question in chat about raising a try except and an accept, and I think Wade has asked it a couple of times.
Sure. Is there a specific piece of code that you'd like to go back to?
It was Wade asking the question. I think he's got a copy paste.
Let's see if there's any questions in the chat. Oh, so can you nest the try, except, and accept? Yes, you can. Yes, you can. Sure thing. Try, I'm going to do 0 division. Right? Actually, boom. So you can nest try except. If you try, you can do pretty much anything you want in Python. So I've nested this try except inside this try except, and then you could stick a finally clause in here, and you can also stick another finally clause here. So the question is, which finally clause is actually triggered? Will it be the inner one? The inner one, if you hit this exception, then the inner final clause will be triggered, and then once that is triggered, then the outer finally clause is also triggered. So basically, this block will be resolved first, and then it goes back to the outer scope. So there's no logical inconsistency. It still works perfectly fine. Does anyone else have any questions? There. So like the nested one is resolved first, prints 1, then it prints 2. So nothing is inconsistent here.
On behalf of Wade, thank you. And on behalf of myself, thank you very much for the informative webinar.
Thanks, Eugene.
All right. Thank you guys for attending this talk, and hopefully there'll be more, and hopefully you learned a lot. So,
That's great.
enjoy Python, keep on going.
And also just wanted to include a couple of concluding words here as well. So Eugene, if you don't mind, could you share the hosting screen?
Can you say that again?
Can you just switch me over to the host?
Yes. So I end my sharing. So
yeah,
there we go. Can you try that now?
Okay. Perfect. So I did want to make a quick note to everyone. There are two callouts. So the first one is that Data Week DC is coming up. If you're not familiar with it, it's a one-week conference where meetups locally organize a bunch of meetups, and it's run for the entire week from October 13th to 17th. And we're going to have some fantastic programming there, so be sure to check it out. The second thing is that we post these sessions online. We currently have 2 of them up, and we will be posting this third one, Pragmatic Python Part 3, under the channel UpSkill ML. So if you guys do want to rewatch and go over this with Eugene again, be sure to check that out on YouTube as part of the UpSkill ML. That's all on our end. Thank you so much for making it out. If you guys do have questions, we'll stick around a little bit longer. But that's all for today.